Okay, we are back on the Drsstc coil build. I moved it out of the garage and into a little bit of a cleaner room. And just so we can take a look at what I've done so far, I have the top primary coil bolted down to the frame with 32 volts, 32 bolts. And I know what you're thinking. There's probably too many bolts. But as my grandmother always said, you can never have too many bolts holding your primary coil on. So, yeah, a little overkill, but that's okay. Now, somebody in the last video left a comment and said that the metal frame might get hot because of inductance. And he said if I put a gap in the frame, it might prevent that problem, that possible problem. So what I did was I reached out to Eastern Voltage Engineering and I presented that issue to them, and I will be showing them photos of this. We'll be talking about that. And I really want to see what Eastern Voltage Engineering says about any problems with having a metal frame that close to the primary coil. And, you know, I do read the comments. I do take the comments to heart, especially with stuff that I really don't know what I'm doing, because with something like this, I honestly really don't know what I'm doing. I can build stuff, I can follow a print, but this is my first high voltage project. I've never done anything with high voltage or high frequency before. So there are lots of stuff I don't know. I don't even know what I don't know. So when somebody posts a comment of a potential problem, I'm definitely going to look into it and check with engineering, get some advice. On the coil, I have the primary connected here and here. That's 5 turns out. That is the way the schematic called for. 2 1/4-inch fuse holders soldered onto the line. So I have that one clipped on there, that one clipped here. And the strike rail, that is connected to a ground wire. Let me see if I can spin this thing around, get a view of that. So this wire here, that is soldered onto a brass tab and hose clamped here. I don't think I like the hose clamp. It works, it'll be fine, but it just looks kind of amateurish. So I might come up with a different solution there. But that goes down and it will be clipped to the frame and goes to our ground right down there. So I have those tabs in solid here and here. The ones on the other corners are bolted to the top of the heatsink, so that heatsink is not going anywhere. Now another commenter, man, I'm gonna mess up the name. D Canada. I think I apologize if I'm screwing up your name. I don't have anything in front of me right now, and it's been a while since I looked at it. But he reached out to me from last video because I was asking about a controller. I was asking if I should get the Eastern Voltage controller or the cheap China controller, and he reached out and offered me a universal controller, which I gladly accepted, and just thank you again. Thank you again for that. That will go right here. Actually, that controller, I already made some mounting brackets and I 3D printed a box to put it in. Here is the controller, and that will mount. There's another piece of that bracket that will actually go, how am I doing it? Like that. So that will get, yeah, can't do this one-handed here. That will get mounted like that, and that will go right in here. Now these brackets are slotted. Let me just sneak that one in here. So notice those slots will go under those nuts. I'll tighten that nut down, tighten that nut down. And then this other bracket here will go under those slots back here, like that. And then that'll get bolted to it. So that will hold that box in there just like that. So that's how that'll look. But I need to do some work to that controller. We'll pull this back out. Because with this controller, with this controller, there's an adjustable inductor that goes there. And he also sent me like a handful of inductors at different values. But I have to figure out what value inductor to go there. It's got to be tuned to match the rest of that. And there's a website that tells you how to do that. Also, I have to adjust, I think, the undervoltage and overcurrent protection. There's a bunch of stuff I need to set and adjust on here. I need a signal generator, and I need a oscilloscope. I have an oscilloscope, and my work has a function generator, but they don't use it very often, so they are in the process of looking for it right now. Hopefully they'll find it by the time I actually need it. So there's a website that talks about how to make all the adjustments to this. And like I said, there's a lot I got to figure out because about half of it is over my head. So I'll probably be reaching out to D. Canada and the guy who sent me this. Again, thank you very, very much. Thank you for that. I do appreciate it. So I'll probably be reaching out to him for help if I can't figure out some of it. But again, that goes there. And of course, these for the feedbacks go to there. And that wire right there for the driver coil connects to there. And this wire, which is the 20 volts AC, 20 or 26 volts AC, I forget what it is, but that'll also go to there. And of course, the fiber optic line goes into there. And I just got a circuit for the interrupter, just a basic interrupter. I'll plug into there for testing. I'll show you that here in a minute. But let's look around the rest of this, because I also got the main power line connected. We spin this around. I've got a 20-foot extension cord. I forget. I think it's rated for 20 amps or something like that. Right now, that is just temporarily strapped there with a zip tie so it doesn't fall out and get all tangled. But I will more than likely build some kind of a bracket off of this to hold the power cable. That power cable comes along through a clamp, and another clamp, and another clamp, and then it comes up. The ground breaks off to my ground post here, which also goes to the ground to the strike rail. And I'll need that other ground for something else. I'm drawing a blank at the moment. And then the power and common coming up, and they go to the main power distribution circuit board here, where we've got fuses. There's the main fuse right up there, and then the fuses for the fan and the power supply. That's the power supply for the controller. It goes there. Again, this is going to give me the 20 to 26 volts AC. And the output line, right now it's just zip tied here. I don't really like the zip ties. They look a little bit amateurish. They will work. I think they're fine. I'm trying to make this look like it was built by somebody who knew what they were doing. I'm trying to make this look, like it was professionally built. So that's why I'm trying to make everything neat and tidy. This will be temporary. What I will probably do, because I need another cooling fan for the heat sink down here. So once I get that cooling fan, I will probably put a distribution block here, cut those wires to the correct length, and then route everything properly. Come up with a way to route those instead of using the zip ties. They don't look horrible. They are functional, but again, I think it just looks a little bit amateurish. Anyways, that's what it's looking like so far. I think it looks like it should work. At this point, though, it wouldn't surprise me if it worked or didn't work. Just because when I look at this whole thing as a whole, it just looks like there's a lot of crap. It looks like there's any one thing that goes wrong could keep this thing from working. But at this point, I could plug it in and it should do something. Maybe. I don't know. I'm not going to yet because I need to adjust and test that. Anyways, that's where that is right now. My next step is to, like I said, adjust and test and set that up and get that mounted and ready to go. And what else? Oh yeah. The secondary, the thing that's missing right there. I need to wind that secondary. I've been putting it off I have everything I need for it. I've just been putting it off. But let me show you the basic interrupter that I made for this. Okay, when you buy the schematics for the Tesla coil, they include a page for a basic interrupter. It's fairly simple. It's only a couple of 555 timers and some kind of a LED driver. I don't know if it's I don't know. And you can buy these already made from their website, tested, built, ready to go. I forget how much they are, but and I was really tempted just to buy theirs, but I'm like, this is fairly simple. I pretty much had everything I needed except for the fiber optic transmitter and that driver. And I'm pretty sure I could have just used a transistor for that, but I'm thinking, somebody who knows more than me spent a lot of time designing this. So they called for that particular IC for a reason. It's a TC4427, and it's just a gate driver is what it's called, 1.5 amp gate driver. So like I said, I'm pretty sure a transistor might have worked, but like I said, they use that for a reason. If a transistor would have worked, they probably would have used a transistor. But anyways, normally when I build a circuit, I'll take the time and etch a board, I'll design and etch a board and print it that way. For this one, I decided not to. A while ago, I bought a whole pack of these off of eBay. They were like dirt cheap. So I decided to just put it on here. And so we have 2 potentiometers. We have the 2 555 timers, the gate driver, and the fiber optic transmitter. I bought that from Eastern Voltage. I also bought this from Eastern Voltage. This is the fiber optic line. This will connect the interrupter to the controller. And it basically just plugs in here. Got to get it lined up. I don't know why it's keyed, but there's a key that has to line up right there. And then you can turn that in and lock that in. When I first got this, I'm thinking they sent me the wrong thing because I didn't realize it was keyed. And that little slot right there has to line up with a peg on the connector, otherwise it won't go in. It goes like that. So anyways, I bought the fiber optic line. I think this is like 10 feet or something like that. But yeah, that connects the interrupter to the controller. And again, 2 potentiometers. One is for frequency, one is for pulse width. And then I have the switch to turn it on. And it just takes a 9-volt battery. And like I said, all I did, and I just put all the components in and just soldered it and did point-to-point wiring. I got a few jumpers on that side. I've got one jumper on that side. It looks ugly. Again, it's just for me, just for testing. It's for me. It works fine. If I was doing this for somebody else, I would have taken the time to etch a printed circuit board because that looks like garbage. And the first time when I turned it on, there's a little LED there to let you know when it's on. And you can look down in there. I don't know if it's going to show in the camera, but you can see the little light shining in there. Doesn't look like the camera's going to pick it up. Not really exciting as is. Can't really see that light in there. But watch what happens when I connect just a little speaker. If I connect this little speaker to the output, I'll just connect that to that, if I can get that to clip on there, to the output, and I'll connect the ground to a ground back here. All right, so now when I push the button, you can hear what that light is doing. And see if I can do this and adjust the pots at the same time. So that is the pulse width. And this one is the frequency. So that tells me that thing works. So I'm happy with that. I tried connecting it to a little cheap China oscilloscope kit. I bought this on eBay a year or 2 ago for like, I don't know, 25 bucks. And I've used it before and it's worked great for other projects, but I just cannot get it to show me anything off of this. But this would not work for that. But the speaker tells me that it works. And so the next step is to build to 3D print a box to put that in, put the switch and the knobs on the top. I'm thinking I might actually put the speaker in with it. You know, have the little speaker mounted somewhere. I'll probably put a little toggle on off switch so I can do it with or without the speaker, because when it's actually driving the Tesla coil, I don't need a speaker on. But just to make sure it's functioning, maybe have the speaker. I don't know. Maybe I will, maybe I won't. I don't know yet. But so yeah, I got a 3D print a box for this. I have to test and adjust and set up the controller and wind the primary coil. And that's pretty much it. So it's getting close. So I'm going to stop right now and do some of that stuff that I just said I need to do. So we'll get back to you here in just a second. Okay, so it has been several days since the last couple of seconds ago that you just saw. So I don't remember exactly where I might have left off, but I do remember we were talking about possibly cutting the frame because a commenter in the last video said that there might be a problem with a metal frame around the primary and might have to cut a gap in it. So what I did was I contacted engineering from Eastern Voltage, which is where I bought the schematics for this from, and I sent a picture of all of this to Eastern Voltage Research, the tech department engineering. I think it's just one guy, maybe, I don't know. And he said that yes, that could get hot from induction, and I should cut about 3 or 4 inches out of it here and here, just so there's not a continuous loop. And as we're emailing back and forth, he said, wait a minute, is that the version 1 Tesla coil? And I said, yes, that's the version 1. And he says, oh, apparently this is a low power Tesla coil, and it might not be powerful enough to heat up the frame. So he suggested to just leave it alone and run it and see if it heats up the frame. And if it doesn't heat up the frame, then don't worry about it. And if it does heat up the frame, then take a few inches out of here and a few inches out of there. And then that's it. So for now, I'm going to leave that as is. Let's go see what I've got on the bench. So there's the controller, and I've got it hooked up to a oscilloscope and a function generator and a power supply. And here is my interrupter box. If I turn the speaker on, so I think you saw that already. You saw the circuit for it, but I don't think you saw that I put it in a 3D printed enclosure. But that is connected, fiber optics, to the board. I know my bench is a mess, but regardless. So right now I'm in the process of setting up and tuning this. Notice I have some LEDs here, and a bunch of, this is for the power coming in from the power supply. Those are signals coming from the function generator for a sine wave, and that is probing for the oscilloscope. And I am really struggling with this because all of this stuff I'm doing now with all of this is, I'm a little out of my comfort range. This is getting way more involved and in depth than I've ever gotten before as far as testing with oscilloscopes and stuff. There's a lot that I don't understand. There's a lot that I'm still learning and figuring out. And I'm learning from the guy who sent me that, D. Canada. So again, thank you. We've been emailing back and forth quite a bit. So I'm gradually getting it. I'm gradually getting smarter, but I still feel really stupid because I'm having a hard time understanding what I'm doing here. What I can show you now is I don't have the I don't have the function generator connected to that anymore. Because I've been experimenting with this thing that I got on eBay. It's a $20 function generator. So I've been experimenting with that, playing around with that. That actually works pretty nicely. I'm not going to turn that on just yet. But what I can show you, I think, just make sure nothing's going to be shorted here. If I turn on the power supply, we got 24 volts here. Notice the status lights here. Now the red light, I'll turn that off real quick. The green LED is power status coming in. The red LED is over current detection or low voltage cutout detection. The blue LED is signals coming from the interrupter right there. So if I push the button on the interrupter, you see the blue LED coming on, telling me that it is getting signals from the interrupter. So that part's working okay. I have been experimenting with putting simulated signals here. It's just a sine wave, and then scoping the output, making sure I'm getting the right output here. I don't want to get into all that just yet because, again, there's still a lot that I'm not understanding. I'm just kind of experimenting and playing around right now. I might, maybe, put out a separate video all about setting up and tuning this. I'm really not the right person to do that because, again, I'm not, an authority on that. I'm the opposite of an authority. What would that be? Anti-authority? I don't know, whatever. I'm not the right person to do a video on that. Somebody should. I have searched eBay and I cannot find a video of somebody showing step by step how to adjust that, set it up, tune it, and all that good kind of stuff. A lot of it I am okay with. One easy thing I can show, I'm just going to turn this off here. One easy thing I can tell you is adjusting the low voltage cutout. That is adjusting. There's a little surface mount potentiometer right there. There's a little pad right there that you put your voltmeter. So you put your voltmeter here, you adjust that here to set your low voltage cutout. The instructions are pretty clear on that. Again, there's a website. If you just do a search for Universal Drsstc controller, you'll find a website talking all about this. Some of the instructions are pretty clear, and most of the instructions, in my opinion, are very vague. And the clear ones I'm okay with. The vague ones are where I'm having problems. So again, somebody needs to do a video of like step by step. Here's where you put your probe, here's where you adjust, here's where you put your multimeter, here's where you put your sine wave, all of that stuff. Somebody needs to put a video out. By the time I'm completely done with the process, maybe I'll have a good enough understanding to where I can just do a video like that. But again, I don't know. And I feel like I'm rambling. So for now, I'm going to end it here. For one thing, that inductor right there, that inductor is the wrong value. The guy who sent me this is in the process of sending me a new inductor for the right value. So for now, I'm kind of at a standstill with this. I'm kind of on hold with this. So what I could do is I could wind the primary. And so what I did, I made this high-tech device, basically a 2x4 and a few pieces of plywood with some rollerblade wheels on it. And a friend of mine asked me one day, he says, hey, I got a bunch of inline skate wheels and bearings if you want the bearings. And I said, yes, please. I know exactly what I'm going to do with it. So thank you, Sean. Appreciate it. So this I will put on the PVC pipe. So now I can like roll that and that'll stay in place. And that is the jig I'm going to use to wind. That's the pipe I'm going to use for the secondary coil. So I'm going to use that to wind the secondary coil. So more than likely, that will just get screwed right down to my workbench when I'm ready to do it. And then that'll go on. And I'll find a slow running electric motor, put a wheel on it to put on here to turn that, probably put a foot pedal switch on it so I can adjust that or turn that on and off with my foot pedal while I wind the copper wire along that. So that's almost ready to start winding. I'm going to leave this video here because it's probably way too long and it's going to be several days before I can really do too much else with this. So I was hoping to have more done at the end of this one, but I'm kind of at a standstill for now. So until next time, and I know it's taken a while, be patient. I'm excited to get this thing going, but I work kind of slow, and this is not my only project. And sometimes it goes on back burner for several days or weeks at a time before I touch it. But it's getting there, it's getting close. So be patient and stay tuned for the next video. Hopefully it won't be too long, probably another week or two. But until then, till next time, as always, thanks for watching.